Hello dear students, today we are going to start the chapter number 5, that is Arithmetic Progression. This is the first lecture of Arithmetic Progression, and in this lecture we will see the basic terms related to Arithmetic Progression and we will see the very basic sum of this chapter. So let's start. First of all, let's understand what is meaning by Arithmetic Progression. So, arithmetic progression is a special type of series in which the difference between consecutive number is remain same. That is known as arithmetic progression. For example, let's see the series here 1, 5, 9, 13, 17, 21 and so on. So, you can observe here that the difference between consecutive number is 4. That is remain same. If you see the difference between 1 and 5, that is 4. The difference between 5 and 9, that is also 4. The difference between 9 and 30, that is also 4. So this series is known as arithmetic progression, and that difference is said to be common difference, indicated by small d. Now let's see. This is the first term of the series, indicated by A1, or simply you can say A. This is the first term, represented by A. 5 is the second term, represented by A2. 9 is the third term, that is A3, A4, like this, A6 and so on. Now, if you want to find the common difference, the formula is successive term minus previous term. To find out the common difference, we will use the formula successive term minus previous term. It means we can do 5 minus 1 or 9 minus 5, or you can say 13 minus 9, like this. So basically you can write the formula of common difference A2 minus A1, or you can write A3 minus A2, or you can write A4 minus A3, like this way. Okay, the successive term minus previous term, then you will get the common difference. Okay. For this series, if you want to find the common difference, you can use any of this formula. For example, if you use A2 minus A1, then in this series you can see A2 is 5 minus A1 is 1. So the common difference of this series is 4. Now let's see the another example. See the another series. This is the first term, that is represented by A1, or simply you can say A. This is the second term, third term, fourth term, like this. Now here, if you want to find the common difference, you can use the formula A2 minus A1. So here A2 is 2 minus A1 is 5. So you'll get the common difference minus 3. So you can see here we get the common difference negative. So here you can see this series is in decreasing order, 5, 2, minus 1, minus 4, minus 7, like this. The series is in decreasing order because the difference is negative. In the previous question we have seen the common difference is positive. Here we get the common difference plus 4. So you can see this series is in increasing order, 1, 5, 9, 13, like this. So in the arithmetic progression, the common difference may be positive or it may be negative, and sometimes it may be 0 also. For example, if I give you one more series here, in this series if you calculate the common difference, you can see the difference between consecutive number is 0. If you want to find out the common difference, You can see A1 is 3, A2 is also 3, A3 is also 3. All the terms are equal. It means the common difference is 0. So, in the arithmetic progression, the difference between consecutive number is remains same. It may be positive, or it may be negative, or it may be 0. The important thing is the difference remains same. Now let's see question number 1. Here one series is given and we have to check whether this given series is an arithmetic progression or not. So we know that if the given series is in arithmetic progression, then difference between successive number will be same. So let's see here, the first term is given 2 plus root 3. Second term is 2 plus 2 root 3. Third term is 2 plus 3 root 3. Fourth term is 2 plus 4 root 3. Now let's see the difference between consecutive numbers. First of all, let's find the difference between second term and first term. So you can see the second term is 2 plus 2 root 3 minus first term is 2 plus root 3. So if you do the subtraction here, 2 minus 2 will be cancelled out, and here 2 root 3 minus root 3. So you'll get the answer root 3. Same way, if you find out the difference between third term and second term, so you can see your third term is 2 plus 3 root 3 minus second term is 2 plus 2 root 3. If you do the subtraction here, 2 minus 2, that becomes 0, and 3 root 3 minus 2 root 3. So you'll get the answer under root 3. Same way, find out the difference between fourth term and third term. And you can see here the fourth term is 2 plus 4 root 3 minus third term is 2 plus 3 root 3. So if you do the simplification here, see 2 minus 2, that will be 0, and 4 root 3 minus 3 root 3. So you will get the answer under root 3. So you can see here that the difference between consecutive number is equal. Hence we can say that the given series is an arithmetic progression. Let's check for the one more example. Here you can see the series is given 1 square, 2 square, 3 square, 4 square, like this, and we have to check whether this given series is an arithmetic progression or not. So let's see here the first term, that is 1 square, that is 1 only. Second term, that is 2 square, that is 4. Third term, that is 3 square, will be equal to 9. Fourth term of this series, that is 4 square, is equal to 16. Now let's find out the difference between the second term and first term. So you can see your second term is 4 and first term is 1, so we'll get the difference 3. Same way, if you find out the difference between third term and second term, third term is 9 and second term is 4, so you get the difference 5. Similarly, find out the difference between fourth term and third term. So fourth term is 16 and third term is 9, so we'll get the difference 7. So you can see here that the difference between consecutive number is not remain same. It means that the given series is not an arithmetic progression. So this way, if you want to find out the whether the series is an arithmetic progression or not, then we will find out the difference between consecutive number. If the difference between consecutive number is remain same, then we can say that given series is an arithmetic progression. If difference is not same, then this series will not be an arithmetic progression. Now let's see the second type of problem. Here in this question, we have to find out first 4 terms of AP. Here the first term A and common difference B are given. Here you can see the first term is given 10 and common difference is 4, and we have to find out first 4 term. So here we know the formula of common difference, A2 minus A1. Okay. Here in this question, the common difference D is given and first term, that is A1, is given to us. So if you want to find out the second term A2, then we can write A2 equal to A1 plus D. So here A1, that is equal to A, that is given 10. So here in place of A1 we will put 10 and common difference D, that is 4. So the second term will be 14. Same way, if you want to find out the third term, then we know the formula for common difference, A3 minus A2. So here we can write A3 equal to A2 plus D. So you can see here A2 is 14 plus common difference, that is 4. So you get the answer 18. Same way, if you want to find out the difference between fourth and third term, then from here you can find out the A4. A4 will be equal to A3 plus D. So A3 is 18 and common difference is 4. So we'll get the answer 22. So this way we will find out the first term of series is 10, second term of series is 14, third term is 18 and fourth term is 22. You can write first term is 10, second term is 14, third term is 18, fourth term is 22, and so on. So this is our required arithmetic progression. So simply you can see here, if you want to find out the second term, we will add common difference into first term. Same way, if you want to find out the third term, we will add common difference into second term. If you want to find the fourth term, we will add the common difference into third term. Like this way, you can find out the successive term of the given arithmetic progression. Now let's solve one more question. Here A is given 4, so we can say A1 is 4 and common difference is minus 3. We have to find out first 4 term of the AP. So first term is already given here, A1, that is 4. Now if you want to find out the second term A2, then we will add the common difference into first term. So we can write the formula here, A1 plus D. So A1 is 4 and common difference is minus 3. So we'll get the answer 1. Same way, if you want to find out the third term, we can add common difference into second term. So second term is 1 and common difference is minus 3. So the third term will be minus 2. Same way, if you want to find out the fourth term, we will add the common difference into third term. So third term is minus 2 and common difference is minus 3. So minus 2, we have plus minus minus, so we will get the answer minus 5. So here in this arithmetic progression, first term is 4, second term is 1, third term is minus 2 and fourth term is minus 5. So series of arithmetic progression will be 4 and 1, minus 2, minus 5, and so on. So this is our required series of arithmetic progression. Now you can solve this third question. Here we want to find out the first 4 term of arithmetic progression. So you can see here the first term is already given. It is a1, that is equal to minus 1, and common difference is minus 1 by 2, or you can say minus 0.5. Now if you want to find out the second term, we will add the common difference into first term, a1 plus d. So first term is minus 1 and common difference is minus 0.5. So we will get the second term minus 1.5. Now if you want to find out the third term, we will add the common difference into second term. So second term is minus 1.5 plus common difference is minus 0.5. So we will get the answer minus 2. And similarly, you can find out the fourth term by adding common difference into third term. So third term is minus 2 and common difference is minus 0.5. So the answer will be minus 2.5. So in this arithmetic progression, first term is minus 1, second term is minus 1.5, third term is minus 2, and fourth term is minus 2.5. So our required AP is first term minus 1, second term minus 1.5, third term minus 2, fourth term minus 2.5, and so on. This is our required arithmetic progression. So this way, whenever the first term and common difference given, then you can find out the arithmetic progression by this way. Now let's see the problems based on word problems. Here in the following situations, we have to check whether the numbers involved make the arithmetic progression or not, and we have to give the reason. So let's check the first problem here. The taxi fare after each kilometer, when the fare is rupees 15 for first kilometer and rupees 8 for each additional kilometer. So you can see here for the first kilometer the fare is rupees 15. So we can say A1 or A, that is the first term, will be 15, and rupees 8 for each additional kilometer. So if you want to find out the fare for 2 kilometer, then for first kilometer we have to pay rupees 15, and for second kilometer we have to add rupees 8. So for 2 kilometer we have to pay rupees 23. Same way, if you want to find out the fare for 3 kilometer, then for 2 kilometer we have to pay 23, and for the third kilometer we have to add rupees 8. So the fare for the 3 kilometer is 31. And same way, if you want to find out the fare for the 4 kilometer, then we will add 31 plus 8. So for 4 kilometer the fare is 39, and so on. So here you can see for 1 kilometer the fare is 15, for 2 kilometer 23, for 3 kilometer 31, for 4 kilometer 39, and so on. So here you can see the difference between consecutive number is remain same. If you find out the difference between second and first, so second is 23 and first term is 15, so the difference is 8. Same way, if you find out the difference between third term and second term, third term is 31 and second term is 23, so the answer is 8. Same way, if you find out the difference between fourth term and third term, fourth term is 39 and third term is 31, so you get the answer 8 only. So here you can see the difference between consecutive number is remain same. So we can say that given series makes an arithmetic progression. Same way, let's solve one more problem. See the second question here. the amount of air present in a cylinder when the vacuum pump removes 1/4 of the air remaining in the cylinder at a time. So, very interesting question this is. If you assume that at a starting of the time, the amount of air present is x. So we can say that first term is x. Now, the vacuum pump will remove 1/4 of the air remaining in the cylinder. So right now we have x amount of air in the cylinder. So vacuum pump will remove 1/4 of the air. So if you subtract x minus 1/4 of x, then you will get 4x minus x divided by 4. That is 3x by 4. So 3x by 4 amount of air will be remaining in the cylinder after removing 1/4 of the air at a time. Now, for the third term, again the vacuum pump will remove 1/4 of the air of the remaining air. So how many air is remaining now? That is 3x by 4. So 1/4 of the 3x by 4 will be removed. So 1/4 of the 3x by 4 that will be removed by the vacuum pump. So if you do this subtraction here, so 3x by 4 minus here this 4 multiplied by 4, that will be 16. So if you take the LCM will be 16, and in the numerator this 3 will multiply with 4, so 4 3s are 12x minus 3x. So the amount of air present in the cylinder will be 9x by 16. So here we get the first term x, second term 3x by 4, and the third term 9x divided by 16. Now we want to check whether this given series form an arithmetic progression or not. So first of all, let's find out the difference between second term and first term. So you can see here second term is 3x by 4 minus first term is x. So if you find out the difference, we will take the LCM. 3x minus this 4 will multiply with x, that is 4x whole divided by 4. So you will get the answer minus x divided by 4. Now same way, if you find out the difference between third term and second term, so the third term is 9x divided by 16 minus second term is 3x divided by 4. So if you take the LCM, it will be 9x minus 12x divided by 16. So this will be minus 3x divided by 16. So you can observe here that the difference between first term and second term is minus x by 4, and difference between third term and second term is minus 3x by 16. So difference between consecutive number is not remain same. So we can say that given series will not form arithmetic progression. Let's see the next type of problem. Here in this question, we have to check that the list of numbers defined by the following nth term is an arithmetic progression or not, and also give the reason. So here in the question you can see the nth term an is given 6 plus 5 plus 6n. So first of all we have to find out the list of numbers, and then we have to check whether this list of numbers are an arithmetic progression or not. So let's see. First of all, if you want to find out the first term, then here in place of n we will put 1. So we will get 5 plus 6 multiplied with 1. So we will get 11. Same way, if you want to find the second term, in place of n we will put 2. So we will get 6 multiplied with 2, 12 plus 5, that is 17. Same way, if you want to find out the third term, we will put 3 in place of n here, so we'll get 18 plus 5, that is 23. And to find out the fourth term, we will put 4 in place of n, so we will get the answer 29. So here we get the list of number 11 and 17, 23, 29 and so on. So here if you see the difference between consecutive number, you find out the difference between second term and first term. So second term is 17 and first term is 11, so the difference is 6. Same way if you see the difference between third term and second term, so the third term is 23 and second term is 17, so we get the difference 6. Same way if you see the difference between fourth term and third term, so fourth term is 29 and third term is 26, so difference is 6. So here in this list of numbers, the difference between consecutive number is remain same, so we can say that given series is an arithmetic progression. Let's see the next problem, same type of problem. So here if you want to find out the list of number, to find out the first number a1, we will put 1 in place of n here, so 3 multiplies 1 minus 2, so we will get the first number 3 minus 2, that is 1. Same way to find out the a2, we will put 2 in place of n here, so we will get 3 multiplies 2 minus 2, so we will get 3 multiplied to 6 minus 2 is 4. Similarly to find out the a3, we will put 3 in place of n, so we will get 9 minus 2, that is 7. And a4, so we will put 4 in place of n, so we will get this is 12 minus 2, that is 10. So here we get the list of number 1, 4, 7, 10 and so on. So if you see the difference between consecutive numbers, the difference between second and first term, second term is 4 and first term is 1, so we get the difference 3. Same way if you see the difference between third term and second term, so the third term is 7 and the second term is 4, so the difference is 3. And same way the difference between fourth term and third term, fourth term is 10 and third term is 7, so difference is 3. So you can see the difference between consecutive number in this series is remain constant, so we can say that given series is an arithmetic progression. So let's see one more problem. Your an is equal to 2n square plus 1 is given. Let's check whether this will form the arithmetic progression or not. So first of all, find out the list of number. To find out the first term, we will put 1 in place of n here. So this will be 1 square, that is 1, multiply 2 plus 1, so we will get the answer 3. Same way if you want to find out the a2, so here in place of n we will put 2, so this is 2 square plus 1. So 2 square is 4, multiply 2, that is 8 plus 1, so we will get the answer 9. To find out the a3, we will put 3 in place of n, so we will get 3 square plus 1. So here 3 square is 9, multiply with 2, that is 18 plus 1, so we get 19. Same way the fourth term we will put 4 in place of n. This is 4 square, that is 16, multiply 2, 32 plus 1, that is 33. So here we get the list of number 3, 9, 19, 33 and so on. So here you can observe the difference between second term and first term. Second term is 9 and first term is 3, so difference is 6. Same way, if you calculate the difference between third term and second term, so the third term is 19 and the second term is 9, so difference is 10. Similarly, if you calculate the difference between fourth term and third term, fourth term is 33 and the third term is 19, so the difference will be 14. So you can observe here that the difference between consecutive number is not remain same, means this will not form an arithmetic progression. So in this lecture we have seen the very basic concept of arithmetic progression, and based on this lecture you can solve this practice problem, and in the next lecture we will start the second topic of this chapter. So bye and have a great day.